Our next technique is distillation. Nice. So in distillation, your aim is to form a distillate, which is a pure solvent. Nice. So what happens in distillation is that you want to separate a solvent from a solution, a particular solvent from a solution. So for you to do this, the solvent can be mixed with a solute, or it can be between two solvents. So, but if it's between two solvents, their boiling points must be duly apart from each other. So the range of their boiling point must be duly apart. Nice. So, but mostly you use this distillation to separate out a solvent, a pure solvent, from a solution. The apparatus for distillation must have, this is the solution. Here, the impure solution, I want to separate out a pure solvent from. So you heat up the solution. Nice. So once you heat up the solution, it's going to form vapors. So this vapors is now channeled towards a condenser called the Lebig condenser. So this condenser is like this. Nice. So you heat up the solution. So once you heat up the solution, the vapors is now channeled towards a Lebig condenser. So this condenser tends to cool this vapor. So because once you cool this vapor is going to form a liquid here, which is the pure solvent. Okay. So this pure solvent here is called the distillate. So this condenser has an inlet for water to enter here. So once water enter here, the water tends to cool down the vapor in this particular pipe. So this is an inlet for water to enter. This is an outlet for water to leave. So this is an apparatus setup for distillation. Our next technique that we'll be discussing is the separation funnel. So this technique is chiefly employed when you want to separate two particular liquids that are immiscible. These are liquids that don't tend to mix well together. For example, you have water and petroleum, example, kerosene. So once these two liquids mix together, they tend to form something like this. So they form two different layers. So this layer can be of water, this one can be of kerosene. So what happens in the separating funnel is that this particular funnel tends to separate out these two immiscible liquids. And once you separate out these immiscible liquids, it now employs their difference in densities. The liquid that is more dense tends to come down below in the beaker, while the liquid that is less dense tends to be at the upper part of the beaker. Nice. So this funnel has an outlet here. As an outlet. Nice. So this outlet will now separate out the more dense liquid from the less dense liquid. Nice. So this technique is employed for what? Immiscible liquids. Liquid that don't tend to mix together. So our next technique is precipitation. Right. So the principle behind precipitation is the difference in solubility. The difference in solubility. Nice. For example, if a solute A is soluble in water, but it is insoluble in ethanol. Once you put a solute A into this water, so you have A plus water here. Nice. So once you now put this ethanol into this solution, solute A will be precipitated out. Mind you, the two solutions that you tend to mix must be miscible. So these two must go together. They must be miscible. Nice. So solute A is soluble in water, but it is not soluble in ethanol. But these two solvents must be miscible. They must mix well together. So when you dissolve solute A in water, for example, so once you introduce this miscible liquid, ethanol, which A is not soluble in, once you put this liquid into this particular solution, solute A will be precipitated out. So that's the principle behind precipitation, difference in solubility. So let's move forward. Our next technique is fractional distillation. So fractional distillation, this is used to separate two or more miscible liquids that have different boiling temperatures. Two or more miscible liquids that have different boiling temperatures. So these liquids, they must be miscible, they must mix so well before you can employ this technique. So the fractional distillation is almost like the distillation, so that a particular apparatus is being introduced. Another apparatus is called the fractionating column. You have a beaker here which you are going to heat up. So that beaker has liquids that are miscible. So these liquids, they can mix so well. Two or more liquids that have different boiling temperatures. Once you heat up these miscible liquids, it's going to be channeled towards a fractionating column. This fractionating column has chambers. So this upper chamber has a lower temperature than the lower chamber. So this is heating. So this upper chamber has a lower temperature than the lower chamber. This column is made up of majorly glass beads. Okay, this fractionating column made up of glass beads. So when you heat up this particular solution, okay, this liquid, the vapor, are going to travel through this column. So through this column, they are going to be funneled towards a condenser, like in distillation. So here you have a condenser too, that will now condense this vapor into pure liquid. So when you are heating up this miscible liquids here, they're going to travel through this column. Like I told you before, this fascinating column, the upper part of the column has a lower temperature than the lower column. So the first vapors that tend to travel here are vapors that have a lower boiling temperature. So these are vapors that are going to synchronize with the lower temperature of this upper column. So what happens here is that once this vapor travel up here, this column is going to select the vapor that has a lower boiling temperature. If you have 3 or more liquids here, say one that have 35 degrees Celsius, 40 degrees Celsius, and 75 degrees Celsius, the one of 35 degrees Celsius is going to travel this column and going to be condensed more than this. So initially, once the one of 35 degrees Celsius reach the upper chamber, like I told you before, this upper chamber has a lower temperature. So it's going to synchronize with this one that have a lower boiling temperature. It's going to condense this first before this. So this is going to keep on happening till the whole liquid here are separated. So as you can see here, this first beaker must have a lower boiling temperature than this one now. So this is the first distillate. This is now a second distillate. So here you have the first distillate. So this is the second distillate. So this particular technique is chiefly employed in petroleum industries when you want to separate the different fractions of this petroleum, like the kerosene, the diesel, and the gases also. So they tend to employ this technique in this industry. So this is our beaker, like I told you before. So this is our fractionating column, while this is now our condenser. So our next technique, which I'm going to discuss, is centrifugation. So this is chiefly employed in the hospitals when you want to separate blood samples. So the principle behind this is that test tubes are put into a centrifuge machine, which tends to spin around to cause more heavier solids to settle at the bottom of this test tubes. Okay. So what happens is that the machine is like somehow round this way, and test tubes are put into the machine. So this machine is going to spin around. So once the spinning is happening, the suspension in this test tube is going to cause the suspension in this test tube to settle down. So the solids tend to settle at the bottom of these test tubes. So that's the principle behind centrifugation. So by so doing, you're going to get a clear liquid on top, which you can now decant. So once you are done with centrifugation, you now decant the top of this test tube that has a pure solvent or pure liquid.